हेलो स्टूडेंट्स, हाउ आर यू? कैसी तैयारी चल रही है? वेलकम टू माय चैनल. टुडे I shall discuss about crystal coordination number. What is crystal coordination number? If you have not subscribed my channel yet, please subscribe it. बहुत लोग चैनल देख रहे हैं लेकिन सब्सक्राइब नहीं कर रहे हैं, तो प्लीज़ सब्सक्राइब द चैनल. Now, the crystal coordination number. What is crystal coordination number? In an ionic crystal, positive ion is surrounded by negative ions and vice versa. Similarly, negative ions are surrounded by positive ions. In ionic crystal, the number of ions of opposite charge surrounding an ion is called crystal coordination number. The crystal coordination number may be defined as the number of ions of opposite charge surrounding an ion in ionic crystal. It is represented by coordination number in short form Cn. It is called Cn. Crystal coordination number or simply coordination number. For example, if we take AB type crystal, for example, sodium chloride, then the coordination number of cation and anion is same. Each sodium ion is surrounded by equidistant 6 chloride ions. Similarly, each chloride ion is surrounded by equidistant 6 sodium ions. Thus, the coordination number of cation and anion is same. But in case of AB2 type crystals, for example calcium chloride, the coordination number of cation and anion is not same. The calcium, for example in calcium chloride, calcium ion is surrounded by 8 fluoride ions, and fluoride ion, each fluoride ion is surrounded by 6 calcium ions. Therefore, the coordination number of calcium ion is 8, but the coordination number of fluoride ion is 4. Now, the radius ratio. What is radius ratio? Radius ratio RR, it is represented by RR. It is defined as the ratio of radius of cation to the ratio to the radius of anion. In an ionic crystal, C plus A minus. If we take ionic crystal C plus A minus, C is cation, A is anion, then the radius ratio may be defined as the radius of cation divided by the radius of anion. This is called radius ratio. With the help of this radius ratio, we can determine the coordination number of cation and anion and also predict the geometry of ionic crystals. This is known as radius ratio effect. Radius ratio effect is, with the help of radius ratio, we can determine the coordination number of cation and anion and the geometry of ionic crystal. This is the chart showing the limiting value of radius ratio and coordination number and geometry of ionic crystals. Geometry of ionic crystals. This is the limiting value of RR, radius ratio. With the increase of RR, radius ratio, the number of anions surrounding the cation increases. As the RR ratio increases, the number of anions surrounding the cation increases. For example, if the limiting value of radius ratio is between 0 to 0.155, then the coordination number is 2 and the geometry of ionic crystal is linear. Ionic crystal will be linear. But if the RR value is between 0.155 to 0.225, then coordination number will be 3 and geometry of ionic crystal will be trigonal planar. For example, boron oxide. Now, if the RR value is between 0.225 to 0.415, then the coordination number will be 4 and the geometry of ionic crystal will be tetrahedral. For example, zinc sulfide. Zinc sulfide has tetrahedral structure. Coordination number is 4. Each zinc ion is surrounded by 6 sulfide ion. Similarly, each sulfide ion is surrounded by 4 zinc ions. Now, if the RR value is between 0.414 to 0.732, then coordination number will be 4 and geometry will be square planar. Similarly, if RR value is 0.414 to 0.732, then coordination number is 6 and the geometry of crystal is octahedral. And common example of this geometry is sodium chloride. But if the radius ratio is between 0.732 to 1.00, then coordination number will be 8 and the ionic crystal has body-centered cubic structure. And common example is cesium chloride crystal. If the RR ratio is 1, this means radius of cation is equal to radius of anion, then coordination number is 12 and the geometry of crystal is CCP cubic closed pact or hexagonal closed pact. The common example of this geometry is metals. All the metals have CCP or SCP structure. Now, how we can apply this limiting ratio, radius ratio rule to determine the coordination number and geometry of ionic crystal? Let us take one example. First example is sodium chloride structure. In case of sodium chloride structure, radius ratio is 0.59 upon 1.81. Radius of sodium ion is 0.51 and chloride ion is 1.81. The radius ratio comes out to be 0.524. This is in this table 0.414 to 0.732. Thus, the radius ratio is between 0.414 to 0.732. Thus, this crystal may have square planar or octahedral geometry. Sodium chloride can have square planar or octahedral geometry. By the X-ray studies, it has been found that NaCl, sodium chloride, has octahedral structure. It means that each sodium ion is surrounded by 6 chloride ions, and similarly each chloride ion is surrounded by 6 equidistant sodium ions. Therefore, the coordination number of sodium chloride is 6:6 and stoichiometry is 1:1 and the stoichiometry is 1:1. Similarly, we can take another example, cesium chloride structure. In case of cesium chloride structure, radius ratio is 1.69 upon 1.81, which comes out to be 0.93, and it lies between the range 0.73 to 1.00. Therefore, the coordination number will be 8. In case of cesium chloride, coordination number will be 8. Thus, each cesium ion is surrounded by equidistant 8 chloride ions, and similarly each chloride ion is surrounded by equidistant 8 cesium ions. Therefore, its coordination number is 8:8. Coordination number is 8:8, and its stoichiometry is 1:1. And cesium chloride, in case of cesium chloride, the stoichiometry is 1:1. In case of sodium chloride, each sodium ion is surrounded by equidistant 6 chloride ions. So today I have discussed about crystal coordination number, radius ratio rule, and its application to predict coordination number and geometry of ionic crystals. Crystal coordination number or coordination number is defined as the number of ions of opposite charge surrounding an ion in an ionic crystal. Radius ratio is defined as the ratio of radius of cation to the radius of anion. Rr is equal to Rc plus upon Ra minus. Rc plus is radius of cation, Ra minus is radius of anion in ionic crystal C plus A minus. This is the chart showing the limiting values of radius ratio. With the help of this chart, we can predict the coordination number and geometry of ionic crystals. If the radius ratio is between 0.225 to 0.414, then coordination number will be 4 and geometry will be tetrahedral. Similarly, if radius ratio is between 0.732 to 1.00, then coordination number is 8 and geometry is BCC, body centered cubic structure. We can apply this rule in case of sodium chloride structure. In case of sodium chloride structure, radius ratios comes out to 0.524. Thus, from this chart, sodium chloride should have either square planar or octahedral arrangement. By X-ray studies, it has been found that it has octahedral arrangement. Thus, sodium chloride has 6:6 coordination number and stoichiometry is 1:1. Thank you for watching my channel. Your comments are welcome. If you have not subscribed my channel yet, please subscribe it. If you have any query in this lecture, you can write in the comment box. Thank you once again.